This is lesson 18.2, sine and cosine ratios. It starts on page 942 in your textbook, so if you pull those pages out, we will go through the notes for sine and cosine. So these are the last two trigonometric ratios. Yesterday we did tangent ratios, and tangent ratios used opposite over adjacent. Today we're going to put sine and cosine together because they do have a relationship with one another. The sine relationship, so the sine of an angle, is the opposite leg over the hypotenuse, and the cosine of an angle, which is abbreviated COS, is the adjacent leg over the hypotenuse. So that's what we're going to do today. We're going to set up ratios using the adjacent and the hypotenuse and the opposite and the hypotenuse. Sometimes we'll have to determine which ratio we want to use. Sometimes we'll be told which ratio to use. But we're going to set those ratios up. Then we're going to use those ratios to find missing side lengths, and we're going to use those ratios, the inverse of those ratios, to find missing angle measurements. So let's start by just setting those ratios up. So remember, when we set up a trigonometric ratio, we are given a specific angle. We're either given an angle by a name or we're given angle theta and told to set up the ratio from that angle. And we look for adjacent, opposite, and hypotenuse in relationship to that angle. So in our first example, we're going to use angle D. Angle D is in the top of this triangle right here, triangle DEF. And from angle D, we're going to do the sine of D. The sine of D says to find the opposite leg and put it over the hypotenuse. So probably the best thing you could do is label your hypotenuse of a triangle before you even start. That way you know exactly where your hypotenuse is. Remember, your hypotenuse is across from the 90-degree angle. So E is my 90-degree angle, so that means DF is my hypotenuse. Then from there, you can label your opposites and your adjacents depending on what angle you're using to create that relationship. So since we're standing right here at angle D at the moment, we're going to put a little mark right there so that's where we know where we're at. And from angle D, the opposite side is the one that doesn't touch angle D. That's all the way over here, and that's side EF. And of course, my hypotenuse is DF. So the sine of angle D is EF over DF. The length of EF is 8. The length of DF is 17. So the sine of D is 8 over 17, which reduces to the decimal 0.471. Now, if we want to do the other trigonometric ratio, which is cosine, we're going to use the same angle. We're going to still stay at angle D. But now we're going to do the adjacent leg over the hypotenuse. So, standing at angle D, the side of the triangle that isn't the hypotenuse that we can reach out and touch is DE. So from D to E is the adjacent leg. And if you want to label these as you go, label them as you go. Labeling things makes sure that you know where everything is at so that you can go back and put it in the ratio in the correct spot. DE measures 15. DF is still the hypotenuse and it still measures 17. So the cosine of angle D is 15 over 17, which as a fraction, or which as a decimal, is 0.882. So that's all we want to do right now is we want to actually just set those ratios up. So in our next example, we're going to use angle F. So I'm going to erase because I'm moving. I'm not going to be in angle D anymore. I'm moving away from angle D. I'm going to erase the things that I've labeled. And now we're here in angle F. And I'm going to put two little marks in there because that's where we're at right now. We want to find the sine of angle F. The sine of angle F, remember sine is opposite over hypotenuse. So from angle F, I'm going to go to the opposite side. The opposite side from angle F is DE, and DE measures 15. And it's over the hypotenuse. The hypotenuse hasn't changed. DF is still the hypotenuse, and it still measures 17. And 15 divided by 17 gives us 0.882. And then we're going to do the cosine of angle F. So this was our opposite. That means this is our adjacent because it's the one we can reach out and touch. And the rule or the ratio for cosine of F is adjacent over hypotenuse. So my adjacent side is 8 and my hypotenuse is still 17. And 8 divided by 17 is still 0.471. I'm going to round that off at the nearest thousandth. So I want you to look at this triangle. We've used the same triangle. We've used angle D and we've used angle F. These angles are complementary to one another because if I knew the measures of these angles, I could add them together and they would add to equal 90 degrees. I want you to look at the sine of D and the cosine of F. Look at the cosine of F and the sine of F, or the cosine of D and the sine of F. And what relationship do you see there? What do you see happening between all of those ratios? Because we're seeing some repetition there. We're seeing that the sine of angle D is the same as the cosine of angle F. We're seeing that the cosine of D is the same as the sine of F. So these complementary angles have relationships with one another when we do the sine and the cosine of those complementary angles. And you're going to see that again in just a moment with another example. So let's go on and let's go down to the bottom of the page and let's look at an example where we need to find the sine and the cosine of an angle. In the right triangle PQR with PR equals 5 and QR equals 3 and the measure of angle Q is 90, what are the values of the sine of P and the cosine of P? Now, you know, you like to think you can do this without actually having a triangle drawn, but probably not. So you're going to have to draw this triangle. So I'm going to start, I know it's a right triangle, so I'm going to start by drawing my 90-degree angle. I'll figure out the rest of it in a minute, and heck, I'll go ahead and put the hypotenuse in there. So we want to label the corners, and luckily it tells me that angle Q is 90 degrees, so I know that Q goes there. It doesn't matter where the P and the R go. They just need to go in the two other corners. Doesn't matter which one is which. And then I'm going to go ahead and label that from P to R is 5, and from Q to R is 3. Now, let's look and see if we have enough information to do the sine of P and the cosine of P. So I'm going to write this down. Sine, if you go back up here, sine is opposite over hypotenuse, so I'm going to write that down. And cosine is adjacent over hypotenuse. The more you write it down, the more likely you are to remember it. If you also look at the reference page that was given to you with your cover sheet, it gives you a whole sentence and some tips on how to remember all of these ratios. So let's start with the sine of P. So we're standing right here. The sine of P is the opposite over the hypotenuse. So I'm going to go opposite, and opposite is QR. So the length of my opposite side is 3. So I'm going to put that 3 there. And then I want to put that over my hypotenuse, and my hypotenuse, which I'm going to go ahead and label, is 5. So my ratio, my sine of angle P is 3 over 5, and 3 divided by 5 is just 0.6. And then we also want to do the cosine of P. The cosine of P says the adjacent over the hypotenuse. Well, the adjacent side would be this side right here, PQ. It's the one that helps make angle P, but it doesn't actually have a value. And nowhere in the problem am I given the value or the distance from P to Q. So I want you to think for just a second, what is the fastest and the easiest way to find the length of PQ? Hopefully you considered the Pythagorean theorem. You're going to find that the Pythagorean theorem inserts itself in geometry over and over and over again. So I'm going to use the Pythagorean theorem to find this missing side length. So I'm going to call this A, this B, and obviously my hypotenuse is always C. So I'm going to say A squared plus 3 squared equals 5 squared. And then 3 squared minus, or 5 squared minus 3 squared is 16. So minus 3 squared minus 3 squared. So A squared equals 16. And I just put that in my calculator. There was nothing magical about that. I just put that in my calculator. And then to find the value of A, I have to take the square root of both sides. So the length of this side, this missing side, is 4. So now I can take this and I can plug it in. My adjacent side is 4. My hypotenuse is 5. And 4 divided by 5 is 0.8. So the ratio for the sine of P is 0.6. The ratio for the cosine of P is 0.8. That's just some basic, let's set these up and make sure we understand where the numbers go in the ratio. So now let's take those basic ratios and let's use them to solve. Actually, let's look at that relationship between the sine and cosine for just a second that we mentioned earlier. So this page 943 in your textbook, refers to trigonometric ratios of complementary angles. Sounds really complicated. It's not. Don't let the big words scare you. It says if angle A and angle B are acute angles in a right triangle, then the sine of A is equal to the cosine of B, and the cosine of B is equal, or the cosine of A is equal to the sine of B. And we saw that back when we did A and B, those first two problems in example 1, where we ended up with all these ratios that were the same. They matched up. So this is really just a way of phrasing that. This is not anything new compared to what we just did a second ago. This is just a different way of phrasing it. So let's take a look at this first example here, letter A. Given that the sine of 38 degrees is approximately 0.616, find the cosine of a complementary angle in terms of the sine of 38 degrees. We're just going to find the sine of that other angle, and we're going to do it in a certain way. We've got a certain setup that we want to use. And we want to use this setup that's in the box up here, where we say the sine of theta, remember theta is just any angle, the sine of an angle is equal to the cosine of 90 minus theta. Or you can turn it around and say that the cosine of an angle is equal to the sine of 90 minus that angle. So that's what we're going to do right down here. We're going to take that setup, the sine of an angle, so the sine of theta, is equal to the cosine of 90 minus theta. Well, in this case, theta is 38 degrees. So we're going to plug that 38 in everywhere it says theta. So 38 says the sine of 38 equals the cosine of 90 minus 38. So we end up with an equation that says the sine of 38 equals the cosine of 52, because 90 minus 38 is 52. Now, basically all we're going to do is we know that the sine of 38 is about 0.616. Be a huge difference. So 0.616 equals the cosine of 52 degrees. It's not, don't overcomplicate this. This is very simple. So let's do another example like that. We're going to start with our setup. It says, given that the cosine of a 60-degree angle equals 0.5, write the sine of a complementary angle in terms of the cosine of 60 degrees. Then find the sine of the complementary angle. So they gave us cosine of 60. So we're going to use the equation cosine of theta equals the sine of 90 minus theta. And we're going to substitute in 60 degrees in both sides. Everywhere there's a theta symbol, we're going to put 60 degrees. So we're going to put 60 degrees here. We're going to put 60 degrees here. So that means the cosine of 60, there was no math to do there, the cosine of 60 is equal to the sine of 90 minus 60. Well, 90 minus 60 is 30. So the cosine of 60 is equal to the sine of 30. Well, we know that the cosine of 60 degrees was 0.5. They told us that right here in the problem. So 0.5 equals the sine of 30 degrees. Let's go to page 944 and do a couple more problems that are very similar to that. In the middle of your page, there's problem 8 and problem 9. It says, given that the cosine of 73 degrees equals 0.292, write the sine of a complementary angle. So we're going to start, they gave us cosine. So we're going to say the cosine of theta is equal to the sine of 90 minus theta. And then we're going to start substituting things in. Everywhere there's a theta, we're going to put 73 degrees. So the cosine of 73 degrees is equal to the sine of 90 minus 73. And then we're going to do the subtraction. The cosine of 73 degrees is equal to the sine of 90 minus 73, which is 17 degrees. And they told us that the cosine was 0.292. So we can say that 0.292 is equal to the sine of 17 degrees. I want you to be able to do this because I want you to be able to use a cosine to find a sine of the complementary angle, or use a sine to find the cosine of the complementary angle. I want you to be able to go back and forth when you're working with complementary angles. The second problem says that given that the sine of 45 degrees is 0.707, find the cosine of a complementary angle. So I'm going to start with what they gave me. The sine of 45 degrees is equal to the cosine of 90 minus 45. I had this formula. Well, I had a similar formula. I took the thetas out. Sine of theta, I replaced it with a 45. Cosine of 90 minus theta, I replaced it with a 45. So the sine of 45 degrees equals the cosine of 45 degrees. Well, they told me that the sine of 45 degrees was 0.707. So 0.707 is equal to the cosine of 45 degrees. Really simple problems. Just make sure that you take the angle measure that they give you and substitute it in for theta. All right, so let's take these ratios and these complementary angles and let's use them to actually solve for some missing pieces of information. So at the bottom of page 944, there's a sketch. It says a 12-foot ramp is installed alongside some steps to provide wheelchair access to a library. The ramp makes an angle of 11 degrees with the ground. Find each dimension to the nearest tenth of a foot. So if you look, we know the length of the ramp. The ramp's 12 feet long. We know that angle A is 11 degrees. We want to know how tall is the porch or the steps in front of the library, and we want to know how far it is from one end of the ramp to the other end of the ramp along the ground. We want that straight line along the ground. So the first thing we're going to do is we're going to solve for x. We're going to figure out how tall the wall is that our ramp is leaned up against. So we start that by doing opposite over hypotenuse. And the opposite side is AB, because remember, we're standing right here. This is the thing we know. We know angle A is 11 degrees. And from here, the wall is opposite of us. So AB is my opposite leg, and that is labeled wrong. My opposite leg should be CB. Well, there's a typo in your book. CB. And my hypotenuse is AC. It's the length of the ramp. So we're going to plug those numbers in. We know that the measure of angle A is 11 degrees. We know that we don't know how tall the wall is. It's labeled X, so we're going to plug in 11. And we know that my hypotenuse is 12. And then we're going to do like we did the other day with tangents. We're going to multiply by whatever's on the bottom of that ratio. So we're going to multiply both sides by 12. And that means this 12 and this 12 are going to cancel out and leave you with an X. And then you have 12 times the sine of 11 degrees. Now, when you plug this into your calculator, you have to make sure that you plug everything in there. It says 12 sine of 11 degrees. So you need to say 12 times the sine of 11 degrees. If you don't tell the calculator sine of 11 degrees, it's just going to multiply 12 and 11, and that's not what we want. And we found, rounded to the nearest tenth of a foot, these numbers match, to the nearest tenth of a foot, the wall is 2.3 feet tall. All right, so let's find how far it is from the wall to the end of the ramp along the ground. So I've redrawn this same picture, and we're going to plug these numbers in we now know we can put that this is 2.3 feet, and we're trying to find y. So we're going to substitute 11 degrees in for A, and here, let's talk about this. Our ratio is the cosine of A. So now we're going to use the adjacent side, and we had to switch to the cosine because this is what we were looking for. This is the angle that we knew. We're looking for the leg that is adjacent to it, so we switched to the cosine. So we're going to do the adjacent leg over the hypotenuse, and the adjacent leg is AB, and the hypotenuse is still AC, and we're going to plug those numbers in. So we're going to plug in 11 for A. For Y, we're going to put Y in for AB, and we're going to put a length of 12 in for AC. So our problem is going to look like this. The cosine of 11 degrees equals Y over 12. And we're going to do the same thing. We're going to multiply by the number that's on the bottom. And we're going to find that 12 times the cosine of 11 equals y. So we multiplied both sides by 12. And then we're going to put that in our calculator, exactly like we see it. We're going to say 12 times the cosine of 11. And we're going to find that y is approximately 11.77 feet long. And they asked us to round to the nearest tenth of a foot. So it's approximately 11.8 feet from the wall along the ground to the end of the ramp. Now, suppose that the law's changed and the regulation now says that the maximum angle of a ramp for wheelchairs is 8%. Our wall is still 2.3 feet tall, but our angle has changed to 8%. We need to figure out how long our ramp needs to be to the nearest tenth of a foot for this new regulation. So we're going to use that 8%. And we have to decide if we're going to use sine or cosine. The only pieces of information we have are how tall the wall is, and we're trying to figure out how long the ramp is. So if I'm standing at angle A, the wall is opposite of me. So I need to ask myself, do I use sine or do I use cosine? Sine uses opposite. So we're going to do sine, and we're going to do opposite over hypotenuse. My opposite length is 2.3 feet, and my hypotenuse is the missing piece of information. Now, I'm going to do the same thing I did in the other two problems, only now when I multiply both sides, I'm going to multiply both sides by z. Because remember, I'm trying to get z by itself, so I got to get it up off the bottom of that fraction. So I have z times the sine of 8 equals 2.3. And I'm going to divide. I'm going to divide by this entire thing. I have to type it into my calculator as the sine of 8. I have to write it on my paper as the sine of 8 because the entire thing is what's going. If you don't take the entire thing, then there's something left over there with the z, and we don't want anything left with the z. So we go to our calculator, and we're going to say 2.3 divided by the sine of 8 degrees. And we're going to find that the ramp is 16.5 feet long. So with the new regulation, the ramp will have to be 16.5 feet in length. The other thing we want to be able to do is we want to be able to find missing angle measures. And we're going to do that the same way we did with tangent. We're going to use the inverse. So the inverse of sine and the inverse of cosine. Still going to use opposite over adjacent or opposite over hypotenuse and adjacent over hypotenuse. We're just going to use inverse when we plug it into our calculator. So at the top of page 946, I'm going to actually skip to this second problem, B. You can go back and look at A if you would like to, but I'm just going to do B. And we're going to set up our ratio. So we're looking for the measurement of angle R. This is what we're looking for. From angle R, we need to use sine because this is our hypotenuse and this is our opposite side. Get the angle down there, the triangle down there. This is our hypotenuse. This is our opposite side. Sine uses opposite over hypotenuse. So I'm going to put opposite over hypotenuse. And the opposite side is 7. And the hypotenuse is 13. So in my calculator, I'm going to type in the inverse of sine 7 divided by 13. So second sine, that gets me the inverse. And then I'm going to say 7 divided by 13. And I'm going to find that the measure of angle R, rounded to the nearest whole degree, is 33 degrees. I want to do the same thing for angle P. I want to find the measure of angle P. But here's something that you have to look at. From angle P, this is not opposite anymore. This is now adjacent from angle P. So I can't use sine this time. I have to use cosine. Remember, because cosine is adjacent over hypotenuse. So I'm going to use the same ratio setup, 7 over 13. But now, in my calculator, I'm going to type in the inverse of cosine. The inverse of cosine, 7 divided by 13. And I'm going to find that the measure of angle P to the nearest degree is 57 degrees. Something I want you to consider is, was there another way to find the measure of angle P? Did you have to do a trigonometric ratio to find the measure of angle P? I'm not going to answer that question just yet. I'm going to go down and we're going to work on number 13 and number 14. Number 13 asks you to find the measure of angle Y. So angle Y is right here. And we need to decide whether we need sine or cosine. So let's label what we have in relationship to angle Y. This is obviously my hypotenuse. And from angle Y, this 14 is adjacent. We've got two choices. We've got cosine, which is adjacent over hypotenuse, and we've got sine, which is opposite over hypotenuse. Well, I have adjacent and hypotenuse, so I'm going to use cosine. So the cosine, or the inverse cosine, because remember I'm looking for an angle measure, the inverse cosine is going to be adjacent, which is 14, over the hypotenuse, which is 23. So in our calculator, we're going to do the inverse cosine, and we're going to do 14 divided by 23, and to the nearest whole degree, that comes out to 53 degrees. So angle Y is 53 degrees. Now we're going to change, and we know what angle Y is now. So I'm going to mark that out because I use that for angle Y. And now I want to figure out what angle Z is. There are two ways to do this. I'm going to do it both ways. I'm going to do the trigonometric way, and then I'm going to do the complementary angle way. The first way is to look at this and go, I have a hypotenuse, and from angle Z, this is now my opposite. So now I can use sine, or the inverse of sine, and I can do my opposite over my hypotenuse, and I'm going to get that the inverse sine of 14 over 35 is 24 degrees. So I could do it like a trigonometric ratio, or I could just do complementary angles. And complementary angles say 90 degrees minus the 53 degrees that are angle Y equals 90 minus 53, which somehow did not give me the right number.